In this video, we're going to look at metallic bonding. We're going to look at what metallic bonding is, metal crystals and the 3D structure of metals, as well as some of the properties of metals, and we're going to link that to how it bonds. When metals bond, the nucleus loses the electrons, and particularly the valence electrons in the outer shell, to the other nuclei around it. So when this atom loses the electrons, it becomes positively charged ion or a cation. So what we have are these metal cations that are floating in a sea of electrons. So the electrons become delocalized and are able to move around between the cations in the lattice structure. So these unbounded or delocalized electrons move around. They are negatively charged, while the cations are positively charged, as I said. So there is an electrostatic attraction between the electrons and the nuclei, and this is what holds the metal atoms in place. So they're actually attracted to the delocalized or the sea of electrons surrounding them. A bit like bricks and mortar. So if you think of the bricks as the cations or the nuclei, and the mortar the electrons surrounding it, holding it together, and that's kind of how metallic bonding works. The difference with metallic bonding is that those, rather than a brick wall, which is solid, those cations, the positively charged nuclei, are allowed to move around and slide over each other in some circumstances. So when we have these cations, they are positively charged, as I said before, and they're generally spherical, consisting of the protons and the neutrons, so spherical-ish, and all of the same size. So we've got a pure metal, so metals all the same metal, they'll all be the same size. Now, different metals, depending on a few of the different properties, like the shape of, or the size of the nuclei, as well as how many electrons it has, can change what structure they pack in. So if you think of it like stacking oranges, for example, there's different ways of packing them together to get them nice and close to each other. In the same way, when metals pack together, or the nuclei of metals pack together, there's different ways that they can pack together. Now, these different ways produce different shaped crystals. We're now going to look at some of the properties of metals. Firstly, as we know, metals are good conductors of electricity, and this is because the electrons, they're free to move around in the lattice, and they are the thing that carries the charge. We know that electricity is the flow of electrons. So here the electrons being free in that sea of delocalized electrons allows those electrons to move from one side to the other. Silver is the best conductor of electricity, and then copper. Metals are also good conductors of heat, because those electrons are able to pick up that heat energy and start vibrating a bit more, and then move around, again be delocalized in the sea, moving that heat energy from one place to another. Metals are malleable, meaning that if you hit them with a hammer, that they'll bend rather than shatter like brittle non-metals will. And this is because, again, of the bonding that is found in metals. So the atoms, or the nuclei, are not in a fixed position, but can move around. So basically what happens is when you hit a metal with a hammer, you're pushing the protons and neutrons around. However, they are still attracted to the electrons, so they won't totally break apart. They'll stay attracted and stay together. For the same reason, metals are ductile, meaning that they can be pulled and stretched into thin wires. And this is because the layers of the nuclei, or the cations, are able to slide across each other while still having that glue, the electrons, or the sea of electrons, holding them together, so they can still stay bound without breaking. In this video, we've looked at metallic bonding, having the positively charged nuclei or cations within a sea of electrons or delocalized electrons that are free to move around. How those cations are packed together affects the crystals that the metals will form. And we've looked at some of the properties of metals, including conductors of both electricity and heat. This is because the electrons are able to move around within that lattice, and that metals are malleable and ductile because as they slide around, the cations slide around over each other, the negatively charged electrons still hold them together and stop them from splitting apart.